Today we'll be taking a look at the form and function along with three features that define the meandering characteristics of Douglas Creek in the district of Saanich, just outside of Victoria, BC. Douglas Creek lies on the western portion of Mount Douglas Park, on the traditional territory of the Saanich people. The creek is part of the Douglas Creek watershed, which covers 524 hectares. Much of the Douglas Creek has been channelized and covered due to development, but 1.1 kilometer of the lower stream remains open as a storm drain outflow into Cordova Bay at Mount Douglas Beach. The section of the stream I'll be visiting today is just below the Ash Road Tunnel off Cedar Hill Road. Douglas Creek is a meandering stream. This is classified as having portions of the stream where the thalweg shifts from one side of the stream bank to the other. As a result of its meander, a cut bank forms where maximum velocity flows on the outside of the bend, and a point bar forms as a result of sediment deposition on the inside of the bend. We can follow the thalweg along the stream. So it enters here, it hits this cut bank here, and then makes a sharp turn to hit this cut bank here. You can follow the bubbles that form along here and the current's moving quite a bit faster. So it ricochets off and moves into the stream. On the other side we have the point bar. There's also a very almost sharp edge here because this is the point bar, but then this is also acting as a cut bank for this sharp diagonal turn that it takes. Under the Köppen-Geiger climate classification, Victoria is a CSB climate. This is characterized as a warm summer Mediterranean climate with the warmest month below 22 degrees Celsius and 4 months above 10 degrees Celsius. Winters are mild but wet, receiving 70% of annual precipitation during the winter months and a pronounced summer drought. Douglas Creek is located west of Mount Douglas in Picoles, Mount Doug Regional Park. The mountain and the surrounding park are densely vegetated, and the summit has an elevation of 225 meters above sea level. To the east of Douglas Creek lies dense urban development. Precipitation that lands on the mountain is directed downward to the base where it enters Douglas Creek. Although the velocity of surface flow increases as it moves down the mountain, the intercepting vegetation acts to slow the rate of surface water entering the creek, and this helps moderate the base flow. The Douglas Creek watershed contains over 30% impervious surfaces. This has an effect on the Douglas Creek streams as surges in stormwater create peak discharge rates after heavy rainfall events. A weir was put in place 20 meters down from the creek channel to mitigate these high flow events. Stormwater surges still have an effect on sediment load as the stream competence and capacity increase, leading to high velocity events which erode stream banks through abrasive action. The first feature is the cut bank. It's the outside bank of a bend which is often eroding and opposite a point bar. You can see how high the creek rises during peak flow events from surrounding impervious surfaces by comparing the current base flow to the edge of where the cut bank has eroded. Restoration efforts were put in place along the lower portion of Douglas Creek. As you can see here, rock armor has been installed to mediate stream bank erosion. This permanent structure is placed where the cut bank would be. On the inside of the bend lies a point bar, and this is our second feature. A point bar is the convex side of a meander bend that's formed as a result of deposition of sediment. The third and final feature is bedload. Bedload is sediment that spends the majority of the time on the bottom of the stream, but it may periodically be entrained and carried a short distance downstream before settling once again. As water from the urban landscape and Mount Doug travel through the storm drain and down the mountain, sediment that's proportional to the velocity of water is carried downstream. It is then deposited along the creek bed where it remains until another precipitation event of equal or greater magnitude provide enough energy to carry that sediment further down the creek and into Cordova Bay. To conclude, Douglas Creek reflects the effects that urban development and impervious surfaces can have on a stream reach, and that no two streams are alike, even though they may share many of the same characteristics, there are many forms in which they may be expressed. This lab helped apply what we learned in class to real-life streams, which not only helped deepen my understanding of fluvial systems, but it was refreshing to complete a lab that wasn't completely computer-based.